Hello, friends. Welcome back to another journey through the cosmos, told softly as always. Tonight, we're going to do something a little different. We're not just going to explore the stars themselves. We're going to explore the stories we've written across them, the ancient tales, the mythologies, the maps drawn by our ancestors who looked up at the same sky you see tonight and saw heroes, monsters, gods, and entire worlds painted in light. Imagine this, 40,000 years ago. No cities, no streetlights, no glow on the horizon. Just you standing on an open plain under a moonless night. Above you, the Milky Way stretches like a river of light, so bright it casts shadows on the ground. You can see thousands of stars, maybe even 10,000 with your naked eye. And in that overwhelming vastness, your brain does something extraordinary. It starts connecting the dots. It finds patterns. It sees shapes where there are none. A hunter, a bear, a serpent coiled across the darkness. This isn't a flaw in how we think. It's a feature. Pattern recognition kept our ancestors alive. It helped them spot predators in the shadows, recognize faces in a crowd, and yes, navigate by the stars. But it also did something more. It turned the night sky into a storybook. If you're enjoying this journey so far, I'd love it if you tap that like button. And if you're new here, consider subscribing. We explore the universe together, one gentle story at a time. Now, let's continue. Here's something fascinating. Constellations aren't real, not in the way we think they are. When you look at Orion the Hunter or Ursa Major, the Great Bear, you're not seeing a group of stars that are actually close together in space. You're seeing stars that just happen to line up from our perspective here on Earth. Some of those stars are hundreds of light years away from each other. They're not connected. They're not a team. They don't even know each other exists. But from where we stand on this tiny blue planet, they look like they belong together. And so, we give them names. We tell stories about them. We pass those stories down through generations. Constellations are a projection. A beautiful human projection of meaning onto the cosmos. Let me show you how dramatic this really is. Go outside tonight if you can. Find a dark spot away from city lights if possible. Look up. If you're in a suburban area in the United States, you might see 200 stars, maybe 300 if you're lucky. That's it. But if you could step back in time or travel to a truly dark sky location like the Atacama Desert in Chile or the Australian outback, you'd see between 4,000 and 6,000 stars with your naked eye alone. Our ancestors saw that every single night. It wasn't special. It was just the sky. Can you imagine what that does to a culture? When every clear night presents you with this overwhelming celestial theater, you don't just glance up and move on. You study it. You memorize it. You begin to notice patterns. You see that certain stars rise at certain times of year. You realize that when this group of stars appears on the eastern horizon at dawn, it's time to plant crops. When that cluster sets in the west, at dusk winter is coming. The stars become your calendar, your compass, your clock. But they become more than that. They become your mythology. See, humans are storytelling creatures. We always have been. We need narratives to make sense of the world. And what better canvas for our greatest stories than the eternal, unchanging sky? Except here's the thing, and this is where it gets even more interesting. The sky isn't unchanging at all. The stars are moving. Slowly, yes. So slowly that in a human lifetime, you'd never notice. But over thousands of years, the constellations we see today will shift. They'll distort. They'll eventually become unrecognizable. The Big Dipper that you know. In 50,000 years, it'll look completely different. In 100,000 years, it won't look like a dipper at all. The handle will stretch the bowl, will scatter, and future humans, if they're still around, will draw entirely different patterns in that part of the sky. They'll tell entirely different stories. So, when we talk about constellations, we're not just talking about astronomy. We're talking about anthropology, psychology, history, art, philosophy. We're talking about what it means to be human. Because every culture that's ever existed has looked up at the stars and done the same thing. They've connected the dots. The ancient Egyptians saw different shapes than the Greeks. The Chinese saw different stories than the Polynesians. The Aboriginal Australians, who have the oldest continuous culture on Earth, stretching back 65,000 years, they saw things no one else did. And here's what's beautiful about that. They were all looking at the same stars, the same sky. But they saw reflections of their own world, their own dreams, their own fears and heroes and gods. Tonight we're going to take a journey through that history. We're going to start at the very beginning with the first people who looked up and tried to make sense of the chaos of stars above them. We'll travel through Mesopotamia, ancient Greece, medieval Europe, and across oceans to cultures that developed entirely separate systems of understanding the cosmos. We'll see how constellations were tools, yes, but also art, how they were science, yes, but also poetry. And we'll discover something surprising. The stories we tell about the stars say just as much about us as they do about the universe. Before we dive deeper, I want you to think about this. Have you ever really looked at the stars? I mean truly looked, not just a glance as you walk to your car, but really stopped and let your eyes adjust to the darkness and tried to see what's there. Most of us haven't. Not because we don't want to, but because we've lost access to the night sky. Light pollution has stolen it from us. In most cities, you're lucky to see a dozen stars. Maybe you can make out Orion in winter or the Big Dipper on a clear night. But that vast river of the Milky Way, the one that ancient people saw every night and built entire mythologies around. For most of us, it's invisible. We've traded the stars for streetlights, and something has been lost in that exchange. Not just astronomical knowledge, but a sense of connection. A reminder of our place in something larger. Our ancestors didn't need a telescope to feel the weight of the cosmos. They felt it every single night. But here's the hopeful part. The stars are still there. They're still shining just as bright as they ever were. And the stories are still there too, waiting, passed down through millennia. Some preserved in ancient texts, some carved into stone, some whispered through oral traditions that stretch back to the very dawn of humanity. And tonight, we're going to open that storybook together. We're going to remember what it was like when humans first looked up, saw the lights in the darkness, and asked the most human question of all. What does it mean? The journey begins not with telescopes or satellites, not with modern astronomy or astrophysics, but with something much simpler. It begins with a group of people thousands of years ago sitting around a fire. Above them, the stars wheel slowly across the heavens. And someone, maybe an elder, maybe a child, points up and says, "Look, do you see it? Right there. That looks like..." And in that moment, a constellation is born. Not in the stars themselves, but in the space between them, in the human imagination. That's where constellations live. And that's where our story begins. So, as we continue this journey together, I want you to hold on to that image, that campfire, those ancient stargazers. Because in many ways, we're still those same people, still looking up, still trying to connect the dots, still telling stories about what we see. The technology has changed. Our understanding of the universe has exploded beyond anything our ancestors could have imagined. But that fundamental human impulse to look at the stars and see meaning, that hasn't changed at all. And maybe it never will. Because constellations aren't about the stars. They're about us. About what we see when we look up. About what we hope and fear and dream. About the stories we need to tell to make sense of this beautiful, bewildering universe we find ourselves in. In a moment, we're going to step back in time, way back, to the cradle of civilization, where the very first constellation maps were carved into clay tablets by candlelight, where astronomers who didn't even call themselves astronomers tracked the movements of planets and predicted eclipses with stunning accuracy, where the zodiac was born not as a horoscope in a magazine, but as a sophisticated system for tracking time and season. We're going to meet the first stargazers, the people who started it all. And we're going to see how their ancient observations, made without any technology beyond the human eye and a lot of patience, laid the foundation for everything that came after. 5,000 years ago, in the land between two rivers, someone made a decision that would change human history forever. They took a piece of wet clay no bigger than a dinner plate and pressed marks into it with a reed stylus. Not random marks, careful ones, deliberate ones. They were making a map, not of roads or cities or territories, but of the sky itself. They were creating the world's first star catalog, and buried in the ruins of ancient Mesopotamia, we found it. Still there, still readable, a voice from 5 millennia ago telling us exactly what they saw when they looked up. This is where it truly begins, not in Greece as many people assume, not in Egypt though they had their own sophisticated system, but in Mesopotamia, in the Fertile Crescent, where the Sumerian and Babylonian civilizations watched the heavens with an intensity and precision that's almost hard to believe. These weren't primitive people making wild guesses about sparkly lights. These were the world's first astronomers, and they were astonishingly good at what they did. If this journey through ancient stargazing is speaking to you, I'd be grateful if you'd hit that like button. It helps more people discover these stories, and if you're enjoying the gentle pace of our explorations, subscribe to join us for more. There's so much universe to discover together. Let's talk about the MUL.APIN tablets. That's their name written in cuneiform, which translates roughly to the plow star. These clay tablets dated to around 1000 BCE, but containing observations that go back much further, perhaps to 3000 BCE, or earlier, are extraordinary documents. They list dozens of stars and constellations. They record their rising and setting times. They track the movements of planets. They predict astronomical events with remarkable accuracy. And here's what makes them so powerful. They weren't made by one person in one night. They represent centuries, possibly millennia of accumulated observations. Grandfather taught father, father taught son. Generation after generation, watching the same stars, refining the same data, building a body of knowledge that would eventually become the foundation of Western astronomy. Think about what that required. Patience, yes. But more than that, it required a belief that the effort mattered, that the patterns in the sky were worth understanding. And they were right. Because in an agricultural society, timing is everything. Plant too early and frost kills your crops. Plant too late and you miss the rainy season. But if you know that when a certain constellation appears on the eastern horizon just before dawn, it's the perfect time to sow barley. Suddenly you have an advantage. You have food security. You have civilization. The Babylonians didn't just watch the stars for practical reasons, though. They believed the heavens and the earth were connected, that what happened up there mattered down here. This wasn't superstition, at least not entirely. It was a sophisticated worldview that saw the cosmos as an integrated whole. When they observed that certain planetary alignments seemed to correlate with political events or natural disasters, they weren't being irrational. They were doing what any scientist does, looking for patterns, testing predictions, building models. Yes, some of those correlations were false, but the method, the systematic observation and record keeping that was sound, that was revolutionary. Let's look at some of the constellations they identified. The ones that are so old, so primal, that they survived the transition from Babylonian astronomy to Greek astronomy to the modern system we use today. The bull, the lion, the scorpion. These aren't arbitrary. They're seasonal markers. In ancient Mesopotamia, the constellation we now call Taurus, the bull, rose in spring. This was the time when bulls were used for plowing fields. The constellation was a reminder, a signal, time to work the earth. The lion, which we call Leo, appeared during the height of summer. Lions were associated with the fierce heat of the sun. And the scorpion Scorpius rose in autumn, when scorpions became more active in the region, seeking shelter as temperatures began to drop. These constellations weren't just pretty pictures. They were functional. They were a calendar written in the sky. But here's where it gets really interesting. The Babylonians divided the sky into three regions. They called them the paths of Anu Enlil, and Ea, named after their gods. The path of Anu ran along the celestial equator. The path of Enlil covered the northern sky. The path of Ea covered the south. Within these paths, they identified specific star groups, and they tracked which ones were visible at different times of year. This system, crude as it might seem compared to modern astronomy, was incredibly effective. It allowed them to create a working model of the sky that could be taught, replicated, and refined over centuries. Now, I want to address a common misconception. Many people think the ancient Greeks invented constellations, that Ptolemy, the great Greek astronomer who lived in Egypt in the 2nd century CE, was the first to systematically catalog the stars. But Ptolemy didn't invent the system. He inherited it. He standardized it, yes. He wrote it down in a form that would survive through the Middle Ages and into the Renaissance. His work, the Almagest, lists 48 constellations that became the core of Western astronomy. But where did those 48 come from? Many of them, perhaps most of them, came from Babylon. The Greeks learned astronomy from the Babylonians. They translated the star names, adapted the myths to fit their own culture, and took credit for a system that was already ancient when Athens was young. This happens a lot in history, doesn't it? The culture that writes things down, that preserves them in a form that survives, gets remembered. The earlier cultures, the ones who did the original work, fade into footnotes. But the MUL.APIN tablets prove that the Babylonians were there first. They were the pioneers, and their work was extraordinary. Let me give you a specific example of just how sophisticated they were. The Babylonians discovered something called the Saros cycle. This is a period of about 18 years, 11 days and 8 hours, after which eclipses repeat in almost the same sequence. If there's a lunar eclipse on a certain date, you can predict with confidence that another eclipse very similar will occur one Saros cycle later. How did they figure this out? By watching for centuries, recording every eclipse, noticing the pattern. And here's the kicker. They didn't have a theory for why this happened. They didn't know about orbital mechanics or the moon's nodes or any of the underlying physics. They just knew that it worked. And they used that knowledge to predict eclipses with stunning accuracy. Imagine the power that gave them to tell a king, in 3 years on this specific day, the sun will go dark, and then to be right. That's not magic, that's science. There's one constellation I want to focus on because it appears across so many cultures that it's almost eerie. The Pleiades. We call them the Seven Sisters today, a small cluster of stars in the constellation Taurus. They're not the brightest stars in the sky. They're not the most dramatic, but they are distinctive, tight, sparkling, unmistakable. The Babylonians saw them. They called them the stars. Simple as that. Just the stars, as if no other group mattered quite as much. The ancient Greeks saw them and told the story of 7 sisters daughters of the Titan Atlas, who were pursued by Orion and transformed into stars by Zeus to protect them. The Maori of New Zealand call them Matariki, and their rising marks the Maori New Year. The Aboriginal Australians, the Japanese, the Hindus, the Aztecs, Native American tribes across North America, all of them identified the Pleiades. All of them told stories about them. And here's what's striking. Many of those stories involve 7 individuals, 7 sisters, 7 maidens, 7 warriors. Why 7? Most people can only see 6 stars with the naked eye. It takes very good vision and very dark skies to see the 7th. But somehow, across continents and centuries, separated by oceans and millennia, different cultures agreed. 7. Was there a time when the 7th star was brighter? When more people could see it easily? We don't know. Or was 7 just a sacred number in so many cultures that it got projected onto the sky? Also possible. But it makes you wonder how much of what we call mythology is actually very old observational astronomy, passed down through stories because there was no other way to preserve it. The Babylonians used the Pleiades as a seasonal marker. Their heliacal rising, That's the first day they become visible just before dawn, after a period of being too close to the sun to see mark the beginning of the agricultural year. Farmers across the ancient world planted crops based on when the Pleiades appeared. This wasn't folklore. This was practical astronomy. And it worked. For thousands of years, it worked. Here's something else the Babylonians gave us: the zodiac. Yes, that zodiac. The 12 constellations that the sun appears to pass through over the course of a year. Aries, Taurus, Gemini, and so on. The Babylonians divided the ecliptic, the path the sun takes across the sky, into 12 equal segments, one for each month. This had nothing to do with astrology, not originally. It was a coordinate system, a way to describe where the sun, moon, and planets were at any given time. It was functional, a tool. Over time, yes, it became associated with divination and horoscopes, but that came later. The original purpose was scientific. It was a calendar and a map combined. And here's the lesson in all of this. The Babylonians show us that science doesn't require modern instruments. It requires curiosity, patience, a willingness to observe carefully and record honestly. They didn't have telescopes, but they had something just as valuable. They had time, generations of time, and they had the humility to know that they were building something larger than themselves, that their children and grandchildren would continue the work. That knowledge was cumulative, that every observation mattered. When we look at the constellations today, when we use the zodiac or talk about Taurus and Scorpius, we're using a system that's 5,000 years old. 5,000 years. Think about that. Empires have risen and fallen. Languages have been born and died. Technologies have come and gone. But those star patterns, those names, they've survived. Because the Babylonians, and before them, the Sumerians, decided that the sky was worth understanding, that the patterns mattered, and they were right. But the Babylonian story is just the beginning. Because while they were developing their system in the Middle East, other cultures were doing the same thing independently on the other side of the world. And the next chapter of our story takes us westward to the civilization that would eventually dominate Western astronomy for 2,000 years. The Greeks didn't invent constellations, but they did something just as important. They turned them into art, into stories so compelling, so dramatic, that they would eclipse almost every other culture's star myths and become the standard we still use today. And that's where we're headed next. There's a family reunion happening right above your head every night, and you've probably never noticed it. A mother chained to a rock, a father holding the severed head of a monster, a daughter transformed into a horse, a sea creature lurking in the depths, and the hero who saved them all frozen forever in the moment of his greatest triumph. This entire mythological drama plays out across the autumn sky, and it's been there in exactly the same place, telling exactly the same story for over 2,000 years. The Greeks didn't just name the stars. They turned the entire night sky into an epic poem. And somehow, their version won. Picture this. Around 150 CE, in the Great Library of Alexandria, a man named Claudius Ptolemy sits surrounded by scrolls, ancient texts, star catalogs from Babylon, from Greece, from Egypt. He's compiling everything known about the heavens into one massive work. He calls it the Almagest, which means the greatest. And in many ways it was. This book would dominate Western astronomy for 14 centuries, 1,400 years. When medieval monks looked up at the stars, they saw what Ptolemy told them to see. When Renaissance artists painted the cosmos, they painted Ptolemy's cosmos. And when we look up today and point out Orion or Pegasus or Andromeda, we're still using Ptolemy's map. He standardized 48 constellations, 48 patterns that would become the canonical star myths of the Western world. If you're captivated by how ancient stories shaped our view of the universe, alike would mean the world. And if you're new here, subscribe to continue this journey through space and time. We have so many more stories waiting among the stars. But here's the question we need to ask. Why did the Greek myths survive when so many others didn't? Why do we know the story of Perseus and Andromeda? But most people have never heard of the Babylonian hero, Gilgamesh's placement in the sky, or the Egyptian goddess Nut swallowing the sun each night. The answer isn't that Greek myths were better or more true. The answer is empire. It's power. It's who gets to write the history books. The Romans conquered the Mediterranean world and adopted Greek culture wholesale. When Christianity spread across Europe, it carried Greek philosophy and Greek astronomy with it. When Islamic scholars preserved ancient knowledge during the European Dark Ages, they preserved Ptolemy's Almagest. And when the Renaissance reawakened European science scholars returned to Greek texts as their foundation. The Greeks won because their empire lasted, because their language became the language of learning, because their stories were written down and copied and translated and taught for 2,000 years. That's how cultural dominance works, not by being right, but by being remembered. Let me tell you the story that dominates the autumn sky, because it's a perfect example of how the Greeks thought about the cosmos. Cassiopeia was a queen of ancient Ethiopia. She was beautiful, and more importantly, she knew it. One day she made a fatal mistake. She boasted that she was more beautiful than the Nereids, the sea nymphs. Now, you don't insult the Nereids. They complained to Poseidon, god of the sea, and Poseidon, never one for proportional responses, sent a sea monster named Cetus to ravage the coast. The oracle said the only way to appease the monster was to sacrifice Cassiopeia's daughter, Andromeda. So they chained this innocent young woman to a rock by the sea and left her to die. Enter Perseus, fresh from killing Medusa the Gorgon. He's flying over the ocean using his magical winged sandals when he spots Andromeda. He falls in love instantly. He makes a deal with her parents. "I'll save your daughter if you let me marry her." They agree. Perseus swoops down, turns the sea monster to stone by showing it Medusa's severed head and saves the day. Everyone lives happily ever after. Well, except Medusa and the sea monster. And depending on which version you read, the guy Andromeda was originally engaged to, who tried to stop the wedding and got turned to stone for his trouble. Now, here's what's extraordinary. Every single character in this story has a constellation. Cassiopeia sits in her chair in the northern sky, circling the pole, star never setting, never resting, eternally punished for her vanity. Andromeda is chained near her arms, outstretched. Perseus stands triumphant nearby, still holding Medusa's head, represented by the star Algol, whose name comes from the Arabic meaning, the demon's head. Cepheus, Andromeda's father, has his constellation. Even Pegasus, the winged horse that sprang from Medusa's blood when Perseus beheaded her, gallops across the sky. And Cetus, the sea monster, lurks down near the southern horizon. It's an entire family drama preserved in stars. You can see it tonight. Go outside in autumn, look north, find the distinctive W shape of Cassiopeia, and you'll see them all frozen in the moment of the story. But the Greeks didn't just tell one story. They told hundreds, and they connected them in ways that turned the night sky into a vast, interconnected mythology. Let's talk about Orion, maybe the most famous constellation in the world. You can see it from anywhere on Earth. It's on the celestial equator, which means both hemispheres get a good view. Those 3 bright stars in a row, that's his belt. The bright red star at his shoulder, that's Betelgeuse. The brilliant blue-white star at his foot, that's Rigel. And depending on which Greek myth you read, Orion was either a great hunter killed by a scorpion, or a hunter who tried to assault the goddess Artemis and was killed by her, or a lover of the goddess Eos who was killed by Artemis out of jealousy. The Greeks couldn't even agree on the story, but they agreed on the constellation. And here's a beautiful detail. Orion and Scorpius, the scorpion that killed him in one version of the myth, are placed on opposite sides of the sky. As Scorpius rises in the east, Orion sets in the west. They're never in the sky together. Even in death, Orion flees from the scorpion. That's not astronomy, that's theater. Now let's talk about something that most people don't realize exists. Asterisms. These are star patterns that aren't official constellations, but are so distinctive that they have their own names. The most famous asterism in the Northern Hemisphere is the Big Dipper. 7 bright stars forming a dipper shape. Everyone knows it. It's often the first star pattern children learn. But here's the thing. The Big Dipper isn't a constellation. It's part of a constellation. Ursa Major, the Great Bear. The dipper forms the bear's hindquarters and tail. The rest of the bear extends out in fainter stars that most people never notice. But the Greeks saw the whole bear, and they told a story about it. Callisto was a nymph who caught the eye of Zeus. Hera, Zeus's wife, was not amused. She transformed Callisto into a bear. Years later, Callisto's son Arcas, now grown, and a hunter encountered a bear in the forest and raised his spear. Zeus, realizing Arcas was about to kill his own mother, intervened. He grabbed both of them by their tails and flung them into the sky so hard that their tails stretched out, which is why the Greeks explained the bears in the sky have such long tails, unlike bears on Earth. It's a ridiculous story if you think about it literally. But that's not the point. The point is that the Greeks needed explanations. They needed the cosmos to make sense. And stories were how they made sense of things. Here's another asterism. The Summer Triangle. 3 bright stars forming a huge triangle that dominates the summer sky. Vega, Deneb, and Altair. Each belongs to a different constellation. Lyra, Cygnus, and Aquila. The Greeks told stories about all 3, but the Summer Triangle as a unified pattern. That's a modern invention. We created a new asterism because the pattern was too obvious to ignore. We're still doing what the Greeks did, still finding shapes, still naming them. The impulse hasn't changed. Let's address something important. Why did Greek myths dominate when other cultures had equally rich star lore? Part of it is timing. The Greeks were active during a period when writing was becoming more common, when trade connected the Mediterranean world, when ideas could spread. But there's another factor. The Greeks were storytellers. Their myths weren't just functional, they were entertaining, dramatic, full of betrayal, heroism, tragedy, and triumph. They were designed to be retold, and they were, in plays, in poems, in histories. Greek mythology became the foundation of Western literature, and because the stars were part of that mythology, they got preserved too. But here's what we've lost in this dominance. Every other culture's stories. The Babylonians had myths for the same constellations. So did the Egyptians, the Persians, the Arabs. Some of those myths survive in fragments and star names that hint at older stories. Betelgeuse, Ragal Aldebaran. These are Arabic names for Greek constellations, showing how Islamic astronomers adopted the Greek system, but kept their own nomenclature. But the stories, most of them, are gone, overwritten, forgotten. And that's a loss. Not a scientific loss, maybe, but a human one. Because every culture's star stories tell us something about that culture. What they valued, what they feared, how they understood their place in the universe. Let me give you one more example of Greek astronomical storytelling that shows how sophisticated they could be. The constellation Gemini, the twins. 2 bright stars, Castor and Pollux, side by side. The Greeks said these were twin brothers, sons of Leda, but only one was immortal. Pollux was the son of Zeus Castor, the son of a mortal king. When Castor died in battle, Pollux was heartbroken. He begged Zeus to let him share his immortality with his brother. Zeus agreed, but with a condition. The twins would alternate, one day in the heavens, one day in the underworld, forever. And so, the Greeks explained why the constellation Gemini is sometimes visible, sometimes not, rising and setting with the seasons. It's a beautiful metaphor for mortality and love and sacrifice. And it's also basic observational astronomy. The constellation is visible in winter, gone in summer. The Greeks wrapped a practical observation in mythological poetry. This is the Greek genius. Not that they invented constellations they didn't, but that they made them unforgettable. They took the Babylonian star catalog and transformed it into story, into art. And that art was so compelling that it erased almost everything that came before it. When we look up tonight and see Perseus or Andromeda or Orion, we're seeing through Greek eyes. We're inheriting their worldview. And for 2,000 years, that seemed like the only worldview, the only way to see the stars. But it isn't. And we're about to discover that when we turn our attention to a part of the sky, the Greeks never saw a part of the heavens that remained unmapped by Western astronomy until the age of exploration forced European sailors to look up and realize they had no idea what they were seeing. Imagine being a sailor in 1595, standing on the deck of a Dutch ship somewhere in the Indian Ocean. You've been at sea for months. Every night you've navigated by the stars, the same stars your father taught you. The same constellations every European sailor has used for centuries. But tonight, something's different. You're far enough south now that the North Star Polaris, your most trusted guide, has disappeared below the horizon. And when you look up, you see stars you've never seen before. Patterns no one in Europe has ever mapped. An entire section of the cosmos that doesn't appear in any book, any chart, any mythology you've ever heard. You are looking at a sky that is, for all practical purposes in your culture's understanding, completely unknown. This is the moment when European astronomy realized it was incomplete. For thousands of years, Western astronomy was built on a fundamental limitation that nobody in Europe understood was a limitation at all. The ancient Greeks, Ptolemy, every astronomer working in the Mediterranean world, they could only see half the sky. The northern celestial hemisphere, everything south of about 35 degrees south, latitude was invisible to them. They didn't know what they were missing because they never traveled far enough south to find out. They thought they had mapped the entire cosmos, when really they'd only mapped the half they could see. It wasn't arrogance exactly. It was geography. You can't map what you can't observe. And for ancient astronomers, the southern sky simply didn't exist. If this revelation about half an invisible sky is surprising you, I'd love to see that reflected in a like. And please subscribe if you're enjoying this gentle exploration through astronomical history. There's still so much more to uncover. But then came the age of exploration. Portuguese sailors pushing down the coast of Africa, Dutch traders heading to the East Indies, Spanish expeditions crossing the Pacific. These weren't scientists. They were merchant soldiers, adventurers. But they were seeing stars that European astronomy couldn't explain. And being practical people, they started making their own maps, rough ones at first, notes in ship logs, sketches. Here around 30 degrees south, there's a cluster of bright stars forming a cross. That was the Southern Cross Crux, now one of the most iconic constellations in the Southern Hemisphere. But in 1500, no one in Europe had a name for it. No mythology explained it. It didn't fit into Ptolemy's system. It was astronomically orphaned. The first real attempt to map the southern skies came from Dutch navigators Peter Dirk Soen, Keizer, and Frederik de Houtman in the 1590s. They were part of the first Dutch expeditions to the East Indies, and they had been specifically instructed to observe and catalog southern stars. They identified 12 new constellations, not reviving old mythology, but creating new ones. And here's where it gets interesting. They named them after animals they encountered on their voyages: the bird of paradise, the toucan, the crane, the peacock, the southern fish. These weren't heroes from ancient epics. These were the exotic creatures they saw in Africa, Asia, and the Americas. Constellations as souvenirs from distant lands. It was astronomy meets travelogue, but the person who really shaped the southern sky was a French astronomer named Nicolas Louis de Lacaille. In the 1750s, he traveled to the Cape of Good Hope in South Africa with a specific mission to map the southern stars with the same precision that northern stars had been mapped. He spent 2 years there, observing every clear night, cataloging nearly 10,000 stars. And in the process, he invented 14 new constellations. 14. That's a significant chunk of the modern sky. But here's what's fascinating about Lacaille's constellations. They have no mythology at all. None. They're named after scientific instruments: the air pump, the microscope, the telescope, the sculptor's workshop, the chemical furnace, the clock, the compass, the octant. These aren't stories, they're tools. And that tells us something profound about how astronomy had changed. By the 1750s, science had divorced itself from mythology. The stars were no longer the realm of gods and heroes. They were objects to be measured, cataloged, understood. And the constellations were just filing systems, ways to organize the sky for reference. Lacaille was a devout man, but when he looked up at the southern sky, he didn't see divine handiwork. He saw a laboratory. There's a certain sadness in that. Don't you think the northern sky is full of stories? Perseus rescuing Andromeda, Orion hunting the great bull, the tragedy of Callisto. But the southern sky, it's full of clocks and microscopes, no stories, no passion, just labels. And it makes you wonder what was lost. Because people lived under that southern sky for tens of thousands of years before Europeans arrived. The indigenous peoples of Australia, Southern Africa, South America, Polynesia, they all had their own constellations, their own myths. But by the time European astronomers arrived with their telescopes and catalogs, they weren't interested in what the locals called those stars. They were interested in claiming them, naming them, making them part of European science. And so, those older names, those older stories were overwritten. Not erased entirely, some survived in oral traditions, but marginalized, made unofficial, turned into folklore, while European names became scientific fact. Let me tell you about one constellation that escaped this fate barely, the Southern Cross Crux. It's the smallest of the 88 modern constellations, but it's probably the most recognizable in the Southern Hemisphere, 4 bright stars forming a distinctive cross. It appears on the flags of Australia, New Zealand, Brazil, Papua, New Guinea, and Samoa. It's a symbol of the South. But here's the thing. The ancient Greeks actually could see the Southern Cross, just barely. From the Mediterranean around 2,000 years ago, due to the precession of the equinoxes, Crux was visible low on the southern horizon. Ptolemy cataloged those stars, but he didn't consider them a separate constellation. He included them as part of Centaurus the Centaur. It wasn't until European sailors started navigating south of the equator that someone looked at those 4 stars and said, "That's not part of the Centaur, that's a cross." And suddenly, Crux became a constellation of its own. It was officially recognized in 1679 by Augustin Royer, but it had been used by navigators for almost 200 years by then. This is a case where practical navigation drove astronomy. Sailors needed to distinguish the Southern Cross from the False Cross, another asterism nearby that looked similar, so they made it official. They gave it a name and a place in the catalog. And that brings us to an uncomfortable truth. The constellations we use today, all 88 of them officially recognized by the International Astronomical Union, they're not neutral. They're not universal. They're a product of European colonialism. When the IAU standardized the constellations, in 1922, they essentially made the European view of the sky the official view. Yes, they included constellations from the ancient Babylonians and Greeks. Yes, they added the southern constellations invented by Dutch and French astronomers, but they didn't include a single constellation from Chinese astronomy, nothing from Aboriginal Australian astronomy, nothing from Polynesian Incan or Native American systems. Those were deemed cultural artifacts, interesting perhaps, but not scientific. And that's a tragedy. Because those systems were just as sophisticated, just as observationally rigorous as anything the Greeks or Babylonians produced. They just didn't come from the culture that won the colonial game. Let's talk about what was lost with a specific example, the emu in the sky. This is an Aboriginal Australian constellation, and it's completely unlike anything in Western astronomy. Most constellations are formed by connecting bright stars, but the emu is formed by the dark patches in the Milky Way. The dark nebulae, the clouds of dust that block the light from stars behind them. When you're in the Australian outback under a truly dark sky, the Milky Way is so bright that these dark patches stand out clearly. And if you know where to look, you can see the shape of a giant emu stretching across the sky. Its head is the Coalsack Nebula near the Southern Cross. Its body extends through Scorpius and Sagittarius. And here's the brilliant part. The emu in the sky is visible at different angles depending on the time of year. When it's standing upright in the sky around April and May, that's when actual emus on the ground are laying eggs. The constellation is a seasonal calendar. It tells you when to look for emu eggs, which were an important food source. That's sophisticated observational astronomy. That's connecting celestial events to terrestrial biology. But it's not in any official catalog. It's not recognized by the IAU. It's just a cultural curiosity as far as mainstream astronomy is concerned. Or take the Polynesian navigation system. Polynesians settled every inhabitable island in the Pacific Ocean, often hundreds or thousands of miles apart, with no instruments beyond their knowledge of the stars, the sun wave patterns, and birds. They had their own star compass dividing the horizon into houses marked by the rising and setting points of specific stars. They didn't think of constellations as fixed pictures in the sky. They thought of stars as tools, as markers. When this star rises, here sail in this direction. When that star sets there, you're on course. It was practical, dynamic, and it worked. But it doesn't fit the European model of constellations as mythological figures. So it's largely ignored in the history of astronomy. Here's the lesson. There is no one correct way to organize the stars. The constellations we use are arbitrary. They're culturally specific. They reflect the values, the stories, the needs of the people who invented them. When European astronomers mapped the southern sky and named it after scientific instruments, they were telling us what they valued: precision, technology, the conquest of nature through understanding. When the Greeks named the northern sky after heroes and gods, they were telling us what they valued: story, drama, the human struggle projected onto the cosmos. When Aboriginal Australians saw emus in the dark patches of the Milky Way, they were telling us what they valued: connection to the land, seasonal awareness, practical knowledge for survival. All of these are valid. All of these are astronomy, but only one of them got written into the official books. The southern sky is a reminder that our view of the cosmos is incomplete. Not scientifically incomplete, we can measure and understand stars regardless of what we call them, but culturally incomplete. We've inherited a system that reflects the worldview of ancient Mesopotamia, classical Greece, and colonial Europe. And we've treated that system as if it's universal, as if there's no other way to look at the stars. But there are other ways, many other ways, and some of them are still alive, still being practiced, still being passed down. Not in universities or observatories, but in communities that never forgot their own star stories. When you look up at the southern sky tonight, if you're fortunate enough to be in the southern hemisphere, you're seeing stars that Ptolemy never saw. Stars that don't appear in Greek mythology, stars that were first mapped by Dutch sailors and French scientists. But you're also seeing stars that were intimately known, by people who lived under them for millennia before any Europeans showed up. And their stories are out there, quieter now, harder to find, but not gone, not yet. And maybe as we become more aware of what was lost, we can start to remember. We can start to honor those other ways of seeing, not to replace the system we have, but to enrich it, to remember that the sky belongs to everyone, and everyone has a right to tell their own stories about it. But speaking of other ways of seeing, we've only scratched the surface. Because while Europeans were slowly discovering the southern sky on the other side of the world, a civilization had been watching the heavens with extraordinary precision for thousands of years. They had their own constellations, their own myths, their own mathematical systems for tracking celestial motion. And their astronomy was in many ways more sophisticated than anything Europe would produce for centuries. We're about to journey east to a culture that saw the sky through completely different eyes. While Greek astronomers were watching the Mediterranean sky and drawing pictures of heroes and monsters on the other side of the world, Chinese astronomers were watching the exact same stars and seeing something completely different. Not mythology, though. They had that too. But structure. Organization, a celestial bureaucracy that mirrored the imperial court on Earth. They divided the sky into 283 distinct asterisms. 283. Compare that to the 88 constellations we use today, or the 48 that Ptolemy cataloged. The Chinese weren't just mapping the sky, they were governing it. And their system was so sophisticated, so mathematically precise, that it operated independently of Western astronomy for over 3,000 years. Two civilizations, same stars, completely different universes. Here's what's extraordinary about Chinese astronomy. It's old, really old. We have star charts from the Warring States period around 400 BCE. We have records of supernovae comets and eclipses dating back even further. The Chinese were systematic record keepers, and they understood something fundamental that would take European astronomy much longer to grasp. The sky changes. Not just the daily rotation or the annual cycle, but real changes. Stars that suddenly appear, stars that fade, objects that move against the fixed background. The Chinese recorded these transient events with obsessive detail. And because of that, modern astronomers can use ancient Chinese records to study historical supernovae and other phenomena. There's a guest star recorded by Chinese astronomers in 1054 CE that appeared near the constellation they called the Horn. It was so bright it was visible during the day for 23 days and remained visible at night for almost 2 years. Today we know exactly what that was. The supernova that created the Crab Nebula. We can still see the remnant. We can measure its expansion. And we know when it exploded because Chinese astronomers wrote it down nearly 1,000 years ago. If you're fascinated by how different cultures created completely separate systems for the same sky, would be wonderful. And if you're new here, subscribe for more gentle explorations of astronomy and history woven together. Let's talk about how the Chinese organize their sky. The foundational system is called the 28 lunar mansions, or Shu in Chinese. These are 28 segments that the moon passes through during its roughly 27-day orbit around Earth. Think of them as celestial waypoints. Each mansion is marked by a specific star or asterism, and together they form a coordinate system that wraps around the celestial equator. This system is incredibly old. It predates most Greek astronomy. Some scholars think it might even have influenced the Babylonian system, though that's debated. What's not debated is how effective it was. Chinese astronomers used the 28 mansions to track the positions of planets, predict eclipses, and create accurate calendars. And unlike the Greek zodiac, which focused on the ecliptic, the path of the sun, the Chinese system focused on the celestial equator, the projection of Earth's equator onto the sky. It's a different reference frame entirely. Same sky, different geometry. The Chinese also divided the sky into larger regions called the 3 enclosures and the 4 symbols. The 3 enclosures are sections of the northern sky centered around the pole star, the purple forbidden enclosure, the supreme palace enclosure, and the heavenly market enclosure. Now, these aren't just poetic names, they're political. The purple forbidden enclosure located around the north celestial pole represented the imperial palace, the emperor, the center of all authority. The pole star itself was the emperor's star, eternal and unmoving, while all other stars revolved around it. That's not accidental symbolism. That's deliberate cosmology. The sky was structured to reflect the perfect order of the empire. And just as earthly officials surrounded the emperor, celestial officials, represented by specific stars, surrounded the pole star. There were stars representing ministers, generals, royal family members, even palace servants. The sky was a mirror of the state. The 4 symbols divided the sky around the celestial equator into 4 quadrants, each associated with a direction, a season, a color, and a mythological creature. The azure dragon of the east associated with spring, the vermilion bird of the south associated with summer, the white tiger of the west associated with autumn, and the black tortoise of the north, sometimes depicted with a snake associated with winter. Each of these contained 7 of the 28 lunar mansions, and each had its own set of asterisms and stories. This is cosmology on a grand scale. The Chinese weren't just naming random star patterns. They were building a system that integrated astronomy, mythology, philosophy, politics, and seasonal observation into one unified framework. It's breathtakingly ambitious. Now, let's compare this directly to the Greek system to see just how different they are. When the Greeks looked at the sky, they saw individual heroes and creatures. Orion is over here, Perseus is over there. Each constellation is its own story. They're connected through mythology, yes, but astronomically they're independent. There's no overarching structure that relates all the constellations to each other. But in the Chinese system, every asterism has a place, a function, a relationship to every other asterism. The sky isn't a collection of stories, it's an organization chart. And that difference reflects something deep about the two cultures. Greek culture celebrated the individual, the hero, the exceptional person who stands out. Chinese culture emphasized hierarchy order and the proper relationship between parts of a whole, and you can see that philosophy written in the stars. Let me tell you about one of the most beautiful stories in Chinese astronomy, the tale of the Weaver Girl and the Cow Herd. In the sky, they're represented by 2 very bright stars. Vega in the constellation, Lyra is the Weaver Girl, Xinyu. Altair in the constellation, Aquila is the cow herd Niu Lang. The story goes like this. Xinyu was a goddess daughter of the celestial emperor skilled at weaving clouds. She fell in love with Niu Lang, a mortal cow herd. They married and had children, and were so happy together that Xinyu stopped weaving and Niu Lang stopped tending his cows. The celestial emperor was furious at this neglect of duty. He separated them, placing them on opposite sides of the Milky Way, the Silver River, as it's called in Chinese. They could see each other, but never touch. Once a year, on the 7th day of the 7th lunar month, a flock of magpies forms a bridge across the Milky Way, and the lovers are reunited for a single night. Then they must part again for another year. This story has been told for over 2,000 years. It's the basis for the Qixi festival, sometimes called Chinese Valentine's Day, still celebrated today. But here's what's astronomically beautiful about it. Vega and Altair really are separated by the Milky Way. They're on opposite sides of that bright band of stars. And they really do seem to approach each other in the sky at certain times of year due to the Earth's orbit and rotation. The story is built on observation. It's mythology that teaches astronomy. When you know the story, you know where to find Vega and Altair. You know what time of year they're most prominent. The myth is a mnemonic device. And that's typical of Chinese astronomy. Stories served a purpose. They weren't just entertainment. They were teaching tools. Here's a question worth considering. If Chinese astronomy was so sophisticated, why didn't it dominate global astronomy the way Greek astronomy did? Why are we using Ptolemy's constellations instead of the 28 lunar mansions? The answer, once again, is empire and cultural exchange. Chinese astronomy developed in relative isolation. China traded with its neighbors certainly, and Chinese astronomical knowledge spread to Korea, Japan, and Vietnam. But it didn't spread to Europe, not in any meaningful way, until very late. When Jesuit missionaries arrived in China in the 16th and 17th centuries, they were stunned by Chinese astronomical records. They recognized immediately that Chinese astronomers had been tracking celestial events with precision that matched or exceeded anything in Europe. But by that time, European astronomy was already entrenched. The Jesuits brought telescopes and European methods to China, and Chinese astronomy began to merge with Western astronomy. But it was a one-way merger. Western astronomy absorbed some Chinese observational data, particularly records of comets and supernovae, but it didn't adopt Chinese constellations or coordinate systems. The Chinese system was too different, too foreign, and ultimately Western science became the global standard not because it was necessarily better, but because Western empires controlled global trade communication and education. There's something else worth noting. Chinese astronomy was intensely political, in a way Western astronomy wasn't. Astronomy in China was a state monopoly. Only the Imperial Observatory was authorized to make certain observations, particularly of planetary positions and eclipses, because these were believed to have political implications. An unexpected comet or eclipse could be interpreted as a sign of heaven's displeasure with the emperor. Accurate prediction of these events was therefore a matter of political stability. If the imperial astronomers could predict an eclipse, it meant the emperor was in harmony with heaven. If an eclipse came as a surprise, it meant trouble. This gave Chinese astronomers extraordinary resources. The emperor funded their work. They had the best instruments, the best training, but it also meant they couldn't share their work freely. Astronomy was a tool of statecraft. That limited its spread. Let's look at one more aspect of Chinese astronomy that shows its sophistication: the precession of the equinoxes. This is the slow wobble of Earth's axis like a spinning top that's winding down, which causes the position of the celestial poles to shift over time. It takes about 26,000 years for one complete cycle. The ancient Greeks knew about precession. Hipparchus discovered it around 130 BCE. But Chinese astronomers were tracking it independently, possibly even earlier. They noticed that the pole star wasn't always in the same position relative to other stars. Over centuries it drifted. They kept meticulous records of this drift, and they understood it had practical implications for their calendar and for navigation. This is advanced observational astronomy. It requires not just careful measurements, but consistency across generations. You have to compare your observations with those made by your predecessors decades or centuries earlier. That Chinese astronomers could do this speaks to the strength of their institutional memory and their commitment to long-term data collection. Here's what all of this tells us. Astronomy isn't just about stars, it's about culture. The way a civilization organizes the sky reflects how they organize themselves. The Greeks saw heroes because they valued individual achievement. The Chinese saw bureaucracy because they valued order and hierarchy. Neither is right or wrong. They're both human responses to the same vast, incomprehensible cosmos, both trying to make it knowable, controllable, safe, and both succeeding in their own way. The tragedy isn't that Chinese and Western astronomy are different. The tragedy is that for most of history, they didn't know about each other. Two incredibly sophisticated systems developing in parallel, solving the same problems with different methods and never sharing notes until it was too late for either to truly influence the other. Imagine what could have been if Chinese and Greek astronomers had been able to collaborate in ancient times. If the Babylonian star catalogs the Greek myths and the Chinese lunar mansions had been combined into a single system. The insights that might have come from comparing observations from different latitudes, the mathematical advances that might have emerged from blending Greek geometry with Chinese algebra. But that's not how history worked. Knowledge developed in pockets. And when those pockets finally connected, one usually dominated, usually the one backed by military and economic power. In this case, that was Europe. And so Chinese astronomy, for all its sophistication, became a historical footnote in most Western textbooks. An interesting curiosity, not the parallel universe of understanding that it actually was, but the stars don't care about our politics or our cultural blind spots. Vega is still the Weaver Girl, even if most Westerners call her just Vega. The purple forbidden enclosure still revolves around the pole star, even if we call it Ursa Minor. The knowledge is still there. The observations, the calculations, the stories, they didn't disappear. They're preserved in ancient texts, in museums, and academic papers. And slowly, as we become more aware of global history, more willing to acknowledge that the Western perspective isn't the only perspective Chinese astronomy is being rediscovered, not as a relic, but as a living tradition with lessons still to teach, about patience, about long-term thinking, about seeing patterns not just in space but in time. about respecting the sky not as a canvas for human stories, but as a system with its own order, its own logic, its own beauty. And this brings us to an even broader question. If the Greeks had their myths and the Chinese had their bureaucracy, what did other cultures see? We've touched on Aboriginal Australians and Polynesians, but there are so many more. Cultures that lived intimately with the sky for millennia, that developed their own sophisticated systems. And many of those systems are still alive, today still being practiced, still being passed down. They're quieter than Chinese or Greek astronomy, less written down, more oral, but no less valuable. And that's where we're going next. There's a knowledge that exists without telescopes, without books, without universities. A knowledge passed voice to voice, generation to generation, for tens of thousands of years. Indigenous peoples around the world have been watching the stars longer than anyone else, longer than the Greeks, longer than the Babylonians, longer than we can easily comprehend. And they've developed astronomical systems so sophisticated, so intricately tied to their land and their survival, that modern scientists are only beginning to understand their depth. These aren't primitive star myths. These are complete sciences, navigation systems that guided voyages across thousands of miles of open ocean, agricultural calendars accurate to within days, cultural knowledge encoded in stories so that it could survive without writing. This is astronomy at its most essential, most human, most alive. Let's start with the oldest continuous culture on Earth. Aboriginal Australians have lived on the Australian continent for at least 65,000 years. 65,000. To put that in perspective, the pyramids of Egypt are about 4,500 years old. Writing itself is only about 5,000 years old. Aboriginal Australians have been telling their star stories for more than 10 times longer than we've been writing things down. And many of those stories are still being told today, still being used, still teaching the sky to new generations. That's not history, that's living astronomy. If this exploration of indigenous knowledge systems is meaningful to you, I'd be honored if you'd tap that like button. And if you're joining us for the first time, subscribe to continue this journey through the many ways humans have understood the cosmos. We have already mentioned the emu in the sky, but let's go deeper into what makes Aboriginal astronomy so unique. Most Western constellations are connect the dots patterns using bright stars, but Aboriginal Australians also recognize dark constellations patterns formed by the dark nebulae and dust clouds that block the light of the Milky Way. When you're in the Australian outback far from any city, lights the Milky Way is so bright and so detailed that these dark patches are obvious. They're not empty space, they're shapes. And Aboriginal people saw animals in them. The emu is the most famous, but there are others. Depending on the region and the language group, there are dark constellations representing kangaroos, sharks, stingrays, and more. This is seeing the sky in a fundamentally different way. Not just what's there, but what's not there. The spaces between the light. That requires a different kind of visual thinking, a different relationship with darkness. And these weren't just pretty pictures, they were functional. The emu in the sky appears at different orientations throughout the year. When the emu is standing upright in the evening sky around April through June, that's when real emus on the ground are laying eggs. It's a direct seasonal calendar. Aboriginal peoples would know by watching the sky exactly when to go looking for emu eggs. And it's not just emus. Different stars and constellations mark the flowering of specific plants, the migration of animals, the arrival of seasonal rains. The sky was a guide to the land. And because Aboriginal cultures were intimately connected to their environment, because survival depended on knowing when and where resources would be available, astronomical knowledge was survival knowledge. It wasn't abstract, it wasn't theoretical. It was practical in the most literal sense. There's something else remarkable about Aboriginal astronomy. It's regional. Different language groups across Australia have different names for constellations, different stories, sometimes entirely different asterisms. But there are common themes. The Pleiades, for example, that cluster we have mentioned before, appears in Aboriginal astronomy across the continent. In some traditions, they're seven sisters fleeing from a man. In others, they're a group of women or young girls. The stories vary, but the seasonal significance is consistent. When the Pleiades rise at dawn in May, it marks the beginning of winter. When they set at dusk in November, it marks the beginning of summer. Different groups use this knowledge for different purposes. Timing fish migrations, knowing when certain plants would be ready to harvest, predicting weather changes. The astronomy was the same, but the application was tailored to local ecology. That's sophisticated environmental science. Now, let's cross an ocean. Let's talk about Polynesian navigation. One of the most extraordinary achievements in human history. Polynesians settled islands across the Pacific Ocean, from Hawaii to New Zealand to Easter Island, spanning an area larger than any other culture's expansion before the age of European exploration. And they did it in outrigger canoes, without compasses, without maps, without any of the tools we think are essential for navigation. They used the stars, they used wave patterns, they used birds, they used clouds, but primarily they used the stars. And their system was so precise that they could sail to a specific island hundreds or even thousands of miles away and arrive exactly where they intended. The Polynesian star compass is one of the most elegant navigation systems ever devised. Imagine the horizon divided into 32 houses, like the points on a compass, but much more detailed. Each house is marked by the rising or setting point of a specific star or group of stars. When you're navigating at night, you identify which house your destination star rises from, and you sail toward that point on the horizon. As stars rise and set throughout the night, you switch reference stars, always keeping your heading aligned with the appropriate house. During the day, you use the sun's position wave patterns and the flight paths of seabirds to maintain course. It's dynamic, it requires constant attention, and it requires memorizing an enormous amount of information. Which stars rise where at which times of year, how currents and winds affect your drift, what the ocean looks like when you're approaching land even when you can't see it yet. This knowledge was passed down orally, often through chants and songs that encoded navigational data. Master navigators could guide their communities across open ocean, for weeks arriving at islands too small to see over the horizon, with a success rate that still amazes modern sailors. Here's a specific example. The Polynesian navigator Mo Piailug from the island of Satawal in Micronesia was one of the last masters of traditional navigation when anthropologists began studying these methods in the 1970s. In 1976, he navigated the Hokulea, a traditionally built double-hulled canoe from Hawaii to Tahiti, a distance of about 2,500 miles, using only traditional methods, no instruments, no GPS. He succeeded, and he proved that the ancient Polynesian voyages weren't lucky accidents. They were intentional, skilled, repeatable. Since then, there's been a revival of traditional Polynesian navigation. New navigators are being trained, the knowledge is being preserved and celebrated, but for a while, it was almost lost. Colonial education systems discouraged traditional practices. Modern technology made them seem obsolete. And as master navigators died without passing on their knowledge, entire systems of understanding vanished. Mau Piailug's willingness to teach non-Polynesians breaking with tradition to ensure the knowledge survived saved an entire science. Let's journey to North America. Native American tribes across the continent have rich astronomical traditions. The Pawnee people of the Great Plains built their entire cosmology around the stars. Their earth lodges were oriented astronomically. The smoke hole at the top represented the sky, and the lodge structure itself was a model of the cosmos. They tracked the movements of Venus, which they called the morning star and evening star, depending on when it appeared, and they used it as a seasonal calendar. The Lakota people recognized specific star patterns that marked important seasonal events. The Hand constellation, which corresponds roughly to part of Orion, told them when to begin preparations for winter. The Chumash people of coastal California were expert astronomers who tracked solstices and lunar cycles with precision. Their rock art includes what appear to be astronomical observations, sun daggers, and star markers carved into stone. And then there are the Pleiades again. This cluster appears in Native American traditions across North America, from the Pacific Northwest to the eastern woodlands. Many tribes call them the Seven Sisters, similar to Greek mythology, but with completely different stories. The Kiowa tell of 7 girls who were chased by a bear and prayed to the Great Spirit for help. The ground rose beneath them, lifting them into the sky where they became stars. The bear tried to follow, clawing at the rock, and that's why Devil's Tower in Wyoming has vertical grooves on its sides. It's a story that connects earthly geography with celestial mythology. The landmark becomes a reminder of the constellation and vice versa. That's integrated environmental knowledge. The landscape and the sky are one continuous story. Let's go south. The Inca civilization in South America had a sophisticated astronomical system that governed their agricultural calendar and religious practices. They recognized dark cloud constellations in the Milky Way, similar to Aboriginal Australians. They saw a llama, a fox, a toad, and other animals in the dark patches. The Inca built astronomical observatories, some of which still stand, structures aligned to solstices and equinoxes. They tracked the Pleiades obsessively. The heliacal rising of the Pleiades, their first appearance in the dawn sky after being hidden by the sun, was one of the most important dates in the Inca calendar. It marked the beginning of the agricultural year. Planting was timed to coincide with this event. If the Pleiades appeared bright and clear, it predicted a good growing season. If they appeared dim or hazy, it predicted drought. Modern studies have confirmed there's a correlation. The atmospheric conditions that make the Pleiades appear dim are associated with El Niño patterns, which do bring drought to the Andes. The Inca were observing real climate predictors encoded in stellar observations. That's not superstition. That's empirical science. Now here's what all of these systems have in common. They're practical. They're tied directly to survival, planting crops, navigating, predicting weather, timing hunts. Indigenous astronomy wasn't about understanding the universe for its own sake, though surely there was wonder and curiosity involved. It was about living in harmony with the cycles of nature, and the stars were the most reliable markers of those cycles. They're visible everywhere. They're consistent. They return year after year in predictable patterns. If you don't have writing, if your culture passes knowledge orally, the stars become a mnemonic device. A way to store information that everyone can access every clear night. There's a beautiful example from Aboriginal Australia that illustrates this. The Yolngu people of Arnhem Land have a story about the Jangawool sisters' ancestral creator beings who traveled across the land, creating features of the landscape. The story is long complex and contains detailed geographical information, where certain water sources are, which paths are safe to travel, where specific plants can be found, and the story is tied to star patterns. As you travel the land during certain times of year, the stars above you correspond to parts of the story. The sky becomes a map. The story becomes navigation. It's a way of encoding critical survival information in a form that's memorable, shareable, and tied to observable phenomena. That's brilliant pedagogy. That's what education looks like in a pre-literate society. But here's the tragedy. So much of this knowledge has been lost. Colonial expansion across the Americas, Australia, Africa, and the Pacific disrupted indigenous societies. Languages were suppressed. Children were taken from their families and educated in Western schools that taught them to ignore or devalue traditional knowledge. Elders died without passing on what they knew, and with them died entire astronomical systems, entire ways of seeing and understanding the sky. We'll never know how many constellations have been forgotten, how many stories, How many practical observations about nature and season and survival? It's an incalculable loss. Not just for indigenous peoples, though, they've borne the brunt of it, but for all of humanity. Because these systems represented different ways of thinking about the cosmos, different approaches to the same questions. And in diversity of thought, there's resilience, there's creativity, there's the possibility of insights we haven't considered yet. There is hope, though. In recent decades, there's been a conscious effort to revive indigenous astronomy. In Australia, Aboriginal elders are working with astronomers to document traditional star knowledge. In Hawaii, Polynesian navigation is being taught to a new generation. Native American tribes are reclaiming their astronomical heritage. These aren't museum exhibits. These aren't historical curiosities. These are living traditions being actively practiced. And modern science is finally recognizing that indigenous knowledge isn't mythology to be dismissed, but empirical observation to be respected. Aboriginal Australians knew about the life cycle of emus. Polynesians knew about ocean currents and stellar positions. The Inca knew about climate patterns. They didn't have the scientific language we use today, but they had the observations. And in many cases, their knowledge was more detailed, more locally specific than anything modern science has since collected. Think about this. What would it mean if we could combine indigenous astronomical knowledge with modern astrophysics? If we could marry the practical land-based seasonal awareness of cultures that lived intimately with the sky for millennia with the telescopes and mathematical models we have today, we might see things we've missed, patterns in nature that Western science overlooked because it was looking through too narrow a lens. We might develop more sustainable ways of living because we'd remember that the sky and the land are connected, that what happens up there matters down here. Not in a mystical sense, but in a real ecological sense. The stars mark the seasons. The seasons govern the behavior of plants and animals. And we, as much as we pretend otherwise, are still part of that system. Indigenous peoples never forgot that. Maybe it's time we remembered. As we've journeyed through different cultural approaches to the stars, from Mesopotamian clay tablets to Greek myths to Chinese bureaucracy to indigenous oral traditions, a pattern emerges. Humans everywhere do the same thing. We look up. We find patterns. We tell stories. We use those stories to make sense of our world and to survive in it. The details differ. The names change. The shapes we see are culturally specific, but the impulse is universal. And that's what constellations really are. Not maps of the stars, but maps of us, our hopes, our needs, our creativity, our relentless drive to find meaning in the cosmos. But now, we need to ask a different question. What are these constellations actually made of? Because as beautiful as the stories are, the reality is even stranger. The 3 stars in Orion's belt look like they belong together. They're aligned, equally spaced, same brightness. When you see them, your brain automatically assumes they're a group, a team. 3 siblings standing side by side. But here's the truth that would have shocked every ancient astronomer who ever lived. Those 3 stars have never met. They don't know each other exists. One of them is 800 light-years away from us. Another is 2,000 light-years away. The third is about 900 light-years away. That means they're separated from each other by distances so vast that light traveling at 186,000 miles per second takes over 1,000 years to cross the space between them. Constellations aren't real objects. They're optical illusions. Beautiful, meaningful, culturally significant optical illusions. And once you understand that the night sky transforms from a picture book into something much stranger, a 3-dimensional universe collapsed into a 2-dimensional projection, and we're the ones doing the collapsing. Let's break down Orion's belt in detail because it's such a perfect example of this cosmic illusion. The 3 stars have names: Alnitak, Alnilam, and Mintaka. All 3 names come from Arabic astronomy, showing again how different cultures contributed to our modern understanding. Alnitak, the easternmost star, is actually a triple star system. What looks like one point of light is actually three stars orbiting each other. It's about 800 light years from Earth. Alnilam, the middle star, is the farthest. It's a blue supergiant, one of the most luminous stars visible to the naked eye, and it sits roughly 2,000 light years away. Mintaka, the westernmost star, is also a multiple star system about 900 light years distant. Now, here's the key insight. If you could travel perpendicular to your line of sight, if you could move to a position 90 degrees around from Earth, these three stars wouldn't line up at all. They'd be scattered across the sky. The belt would disappear. The constellation only exists from our perspective. Change your perspective and it vanishes. If this revelation about the three-dimensional reality behind our flat constellations is blowing your mind a little, I'd love it if you'd hit that like button. And if you're curious to learn more about the universe as it actually is beyond the stories, please subscribe. There's so much more to explore together. Here's another way to think about it. Imagine you're standing in a field at night. In the distance, you see three lights. They look like they're in a line. You assume they're connected. Maybe they're streetlights along a road. But when you walk closer, you discover one light is a candle on a table 10 feet away. Another is a porch light on a house 100 yards away. The third is a radio tower 5 miles away. They only looked aligned because of your position. That's what's happening with constellations. We're seeing stars at wildly different distances projected onto the celestial sphere, and our brains are pattern-matching machines. They see the alignment and create the connection. Now, let's talk about something that makes this even more interesting. Proper motion. Stars aren't fixed, they're moving. Every star in the sky is traveling through space at tremendous speeds. Our sun is moving at about 45,000 miles per hour relative to nearby stars. Other stars are moving at different speeds and different directions. But space is so vast and stars are so far apart that this motion is almost imperceptible. Almost. Over thousands of years, though, it adds up. The constellations we see today are not the constellations ancient humans saw, and they're not the constellations our descendants will see. Let's look at the Big Dipper as an example. Right now, it looks like a dipper, a bowl with a handle, 7 stars forming a distinctive shape. But if you could see the Big Dipper as it appeared 100,000 years ago, you wouldn't recognize it. The handle would be straighter. The bowl would be shallower. The stars would still be there, but in different positions, and the shape would be different. Now, look forward. If you could see the Big Dipper as it will appear 100,000 years from now, it will look even more different. The handle will curve in the opposite direction. The bowl will be deeper. Eventually, in hundreds of thousands of years, it won't look like a dipper at all. The constellation will dissolve. Future humans, if they're still around and still looking up, will draw entirely different patterns in that part of the sky. They'll tell different stories, and they'll think their constellations are eternal, just like we do. This happens because stars are moving in 3 dimensions. Some are moving toward us, some are moving away, some are moving across our line of sight. And they're all moving at different rates. The stars in the Big Dipper aren't gravitationally bound. They're not a cluster. They're just stars that happen to be in the same general direction, from our viewpoint, each doing its own thing. Over time, that changes the picture. There's something beautifully poetic about this. The constellations that ancient peoples saw, the ones they used for navigation and agriculture and mythology, those exact patterns will never exist again. They're gone. Slowly transformed by the motion of stars, and the constellations we see now will in turn become unrecognizable. We're living in one snapshot of a constantly changing cosmos. The stories we've told about these star patterns, stories that have survived for millennia, are stories about configurations that are temporary. Nothing in the universe is permanent, not even the pictures we draw in the sky. Now you might wonder, if constellations aren't real objects, why do astronomers still use them? Why do we still divide the sky into 88 official constellations? The answer is simple. They're useful. Not scientifically, but organizationally. Think of constellations as celestial zip codes. When an astronomer discovers a supernova, They need a quick way to tell other astronomers where to look. Saying, "It's in Andromeda," immediately narrows down the search to a specific region of sky. Saying, "It's at right ascension, 0 hours, 42 minutes, declination, plus 41 degrees," is more precise but harder to remember and communicate quickly. Constellations are a rough coordinate system. They divide the sky into named regions. And because they're culturally familiar, because they've been used for so long, they persist. In 1922, the International Astronomical Union officially designated 88 constellations and defined their exact boundaries. Not the mythological shapes, but the regions of sky those names refer to. Every point in the sky belongs to exactly one constellation. It's like dividing a map into counties. The boundaries are arbitrary, but once everyone agrees on them, they're useful for reference. Let me give you an example of how this works in practice. The Hubble Space Telescope has taken thousands of stunning images of galaxies, nebulae, and other deep sky objects. When astronomers publish papers about these observations, they'll often reference which constellation the object is located in. The Crab Nebula is in Taurus. The Andromeda Galaxy is obviously in Andromeda. These objects are millions or billions of light years away. They have nothing to do with the foreground stars that form the constellation. But the constellation name serves as a convenient label for that direction in space. It's shorthand. And it works because everyone knows what you mean. Here's another fascinating layer to this. Because constellations are perspective-dependent aliens on another planet, would see completely different patterns. Imagine a civilization orbiting a star 100 light years from Earth. When they look at our sun, it's just another faint star in their sky. And when they look at the stars we call Orion, they see them from a different angle. The belt doesn't line up. The hourglass shape is distorted. They would draw entirely different constellations based on their viewpoint. And their constellations would be just as valid and just as arbitrary as ours. There's no privileged perspective in the universe, no correct way to group the stars. It's all about where you're standing. This raises a profound question. If we ever make contact with an extraterrestrial civilization, will we have any common reference points for discussing the locations of stars and galaxies? The answer is yes, but not through constellations. We'd need to use something more universal. Coordinates based on measurable phenomena, the plane of the Milky Way galaxy, the cosmic microwave background, pulsars with distinctive timing signatures, things that any technological civilization could observe and measure. Constellations are too human, too Earth-centric. They're one of the few aspects of astronomy that doesn't translate across interstellar distances. Let's talk about stellar distances more concretely. When you look at a constellation like Cassiopeia, that distinctive W shape in the northern sky, you're looking at stars at vastly different distances. The nearest star in Cassiopeia is Eta Cassiopeiae, about 19 light-years away. The farthest bright star in the constellation is Gamma Cassiopeiae, about 550 light-years away. That's a difference of over 500 light-years. If you could fly toward Cassiopeia at the speed of light, it would take you 19 years to reach the nearest star and over 500 years to reach the farthest. During that journey, the constellation would slowly dissolve. Stars that appeared close together would separate. New stars would come into view. The entire shape would warp and distort until it was unrecognizable. And that's assuming you're traveling in a straight line. If you deviated even slightly, you'd pass some stars by millions of miles and never see others at all. The constellation only exists along one specific line of sight, ours. Now, here's a common misconception I want to address. Some people think that because constellations aren't real physical groups, they're not important, that they're just ancient superstition we should abandon, but that's missing the point. Constellations are culturally real, they're cognitively real. They represent how humans naturally perceive and organize information. Our brains are pattern recognition engines. We see faces in clouds. We hear messages in random noise. We find shapes in stars. That's not a bug. That's a feature. It's how we make sense of a complex, overwhelming world. And the fact that the patterns aren't objectively present doesn't make them meaningless. Art isn't objectively present in paint and canvas, but we don't dismiss art as meaningless. Stories aren't objectively present in words on a page, but stories matter. Constellations are the same. They're human creations, projections of meaning onto nature. And that's okay. That's what makes them valuable. There's also a practical aspect. Constellations help us learn the sky. If you're trying to teach someone astronomy, you could start by giving them precise coordinates for thousands of stars. Or you could say, find Orion, see the 3 stars in a row. Now look just below them. That's where the Orion Nebula is. The constellation provides context, a landmark, a starting point. Once you know Orion, you can find other constellations nearby. Follow the belt to the left, and you'll reach Sirius, the brightest star in the night sky, part of Canis Major. Follow it to the right, and you'll reach Aldebaran, the eye of Taurus. The constellations form a network of relationships, a web of navigation across the sky. And that's useful even for modern astronomers. So, yes, constellations are illusions. They're human-drawn patterns that have no physical reality beyond our perspective. The stars don't care what shapes we see in them. They're separated by distances so immense that light takes centuries or millennia to cross the gaps. They're moving slowly but inevitably transforming the patterns we've memorized into new configurations we won't recognize. But none of that diminishes their importance, because constellations were never about the stars. They were about us, about how we see, how we remember, how we orient ourselves in space and time, how we tell stories that bind communities together and pass knowledge across generations. Constellations are maps not of the stars, but of human cognition and culture. And from that perspective, they're as real as anything else we've created, as real as language, as real as art, as real as love. The stars will continue their slow dance through the galaxy. The constellations will continue to shift and dissolve. But as long as humans look up at the sky and see patterns, as long as we need to make sense of the vastness above us, we'll keep drawing pictures in the stars. We'll keep telling stories. And maybe that's the most human thing we do. Not understanding the universe as it objectively is, though we try, but creating meaning where none inherently exists, building bridges between ourselves and the infinite, finding connection in light that has traveled across the void of space just to reach our eyes. That's what constellations are, and that's why they'll never truly disappear. Because the stars might change, but we're still the same pattern-seeking, storytelling creatures we've always been. And speaking of stories, we're about to explore how those ancient star myths have evolved, adapted, and survived into the modern age in ways you might not expect. You've been lied to about the Big Dipper, not maliciously, but consistently. Everyone calls it a constellation. It's on children's books about astronomy. It's the first star pattern most people learn. Teachers point it out. Parents show it to their kids. There's the Big Dipper up in the northern sky. But here's the truth. The Big Dipper isn't a constellation at all. It's an asterism, a smaller pattern within a larger constellation. The actual constellation is called Ursa Major, the Great Bear, and the Big Dipper. That's just the bear's hindquarters and tail, 7 stars out of dozens. But those 7 stars are so distinctive, so easy to recognize that they have overshadowed the entire constellation. Most people have never seen the rest of the bear. They don't know it exists. And that tells us something important about how we remember the sky. We don't remember the official designations. We remember the patterns that work for us, the ones that are simple, distinctive, and useful. And sometimes those patterns become more famous than the constellations they belong to. An asterism is a recognizable pattern of stars that isn't one of the 88 official constellations. It can be part of a constellation like the Big Dipper within Ursa Major, or it can span multiple constellations like the Summer Triangle, which connects Vega in Lyra Deneb in Cygnus and Altair in Aquila. Asterisms are unofficial. They're not regulated by the International Astronomical Union. But they're incredibly useful for amateur astronomers because they're often easier to spot than the full constellation shapes. They're the landmarks that help you navigate the sky. If you're enjoying this deep dive into how we've organized and reorganized the stars throughout history, a like would be wonderful. And if you want to continue exploring these cosmic connections, please subscribe. We're almost at the end of this journey, but there's still one more chapter to tell. Let's talk about the most famous asterism of all, at least in the Northern Hemisphere, the Big Dipper. 7 stars. 4 forming the bowl, 3 forming the handle. It's circumpolar at northern latitudes, meaning it never sets below the horizon. You can see it any clear night of the year, though it rotates around the North Star. The ancient Greeks saw this same pattern and called it part of a bear. The Romans agreed. Native Americans saw it too, and many tribes also interpreted it as a bear independently arriving at the same conclusion. That's remarkable. Different cultures separated by oceans and millennia looked at 7 stars and thought, bear. Though why some researchers think it's because the long tail of stars resembles a bear standing on its hind legs. Others think it's coincidence amplified by cultural exchange. We'll probably never know for certain. But the Big Dipper has been recognized as a distinct pattern for thousands of years, and it remains one of the most universally known star patterns in the world. The Big Dipper is also incredibly useful for navigation. The 2 stars at the end of the Dipper's bowl, Dubhe and Meroc, are called the pointer stars. If you draw an imaginary line through them and extend it about 5 times the distance between them, you'll hit Polaris, the North Star. And Polaris marks the North Celestial Pole. It's how you find north without a compass. Sailors used this technique for centuries. Escaped slaves in America used it to navigate toward freedom along the Underground Railroad. The Big Dipper wasn't just a pretty pattern. It was a tool, a lifeline. And that's why it remained important even as scientific astronomy moved beyond simple star patterns. But asterisms aren't just ancient. We're still creating new ones. The winter hexagon is a modern asterism connecting 6 bright stars from 6 different constellations: Rigel, in Orion Aldebaran, in Taurus Capella, in Auriga Pollux, in Gemini, Procyon, in Canis Minor, and Sirius, in Canis Major. It forms a huge hexagon that dominates the winter evening sky in the Northern Hemisphere. This pattern isn't ancient. It was only formally recognized in the 20th century. But it's useful for learning the winter constellations, because once you can identify the hexagon, you can identify all 6 constellations at once. Asterisms are teaching tools. They simplify the complexity of the sky into manageable chunks. Now, let's talk about something that almost everyone has heard of, but few people truly understand: the zodiac. You know your zodiac sign, probably. Maybe you're a Leo or a Pisces or a Gemini. Maybe you read your horoscope occasionally taking it seriously or treating it as entertainment. But do you know what the zodiac actually is? Astronomically, I mean, not astrologically. The zodiac is a band of sky about 8 degrees wide on either side of the ecliptic, which is the apparent path the sun traces across the sky over the course of a year. As Earth orbits the sun from our perspective, the sun appears to move through different constellations. It spends about a month in each one. Those 12 constellations are the zodiac: Aries, Taurus, Gemini, Cancer, Leo, Virgo, Libra, Scorpius, Sagittarius, Capricornus, Aquarius, and Pisces. This system is ancient. The Babylonians developed it over 2,500 years ago as a way to track time and create calendars. Each zodiac constellation marked a different month. It was practical astronomy. But here's the thing that most people don't realize. The zodiac has changed since ancient times, and your zodiac sign is probably wrong. Here's why. Earth wobbles on its axis, not quickly but steadily. This wobble is called precession, and it takes about 26,000 years to complete one full cycle. Because of this wobble, the position of the sun relative to the background stars on any given date shifts slowly over centuries. When the Babylonians defined the zodiac, the sun was in Aries during the spring equinox. That's why Aries is the first sign of the zodiac. But today, due to precession, the sun is in Pisces during the spring equinox, and it's moving toward Aquarius, which is why you sometimes hear about the age of Aquarius. The entire zodiac has shifted by almost one full sign since it was created. So if you think you're a Leo because you were born in early August, astronomically, the sun was probably in Cancer when you were born, not Leo. Your astrological sign is based on where the sun was 2,000 years ago, not where it actually was when you were born. There's another complication. The zodiac officially has 13 constellations, not 12. Between Scorpius and Sagittarius, the ecliptic passes through a constellation called Ophiuchus, the serpent bearer. The sun spends about 18 days in Ophiuchus each year, from roughly November the 30th to December 18th. But Ophiuchus isn't part of the traditional zodiac. Why? Because the Babylonians wanted 12 signs to match their 12-month calendar. 13 was inconvenient, so they just ignored Ophiuchus. And that convention has persisted for 2,500 years. Every few years, someone discovers this fact and writes a headline like, NASA announces new zodiac sign. And people panic thinking their astrological identity has changed, but it hasn't. Astrological zodiac signs were never meant to be astronomically accurate. They're symbolic. They're based on tradition, not observation. And that's fine, as long as everyone understands the distinction. Astronomy and astrology parted ways a long time ago. They're not the same thing. Here's my question for you. Do you think there's any value in astrology, even if it's not scientifically accurate? Or should we abandon it entirely as superstition? It's an interesting cultural question. Astrology has existed for millennia. It's deeply embedded in many cultures. And even people who don't believe in it often know their zodiac sign. It's a form of identity, a way of categorizing personality types. Maybe it's harmless fun. Maybe it's a distraction from real astronomy. I'm curious what you think. Let's shift to something more lighthearted. Constellations in pop culture. The stars have always captured human imagination, and in the modern era, that's translated into movies, books, music, and even corporate logos. Superman's home planet Krypton orbits a red star. In the original comics, it wasn't specified which star, but later versions placed Krypton in a real star system, the star LHS 2520, a red dwarf about 27 light-years from Earth. That's a real star. You could point a telescope at it. You won't find Krypton, obviously, but it's a nice touch. It grounds the mythology in actual astronomy. The movie Interstellar featured a black hole called Gargantua that was so scientifically accurate in its depiction that the visual effects team worked with physicist Kip Thorne to ensure the light-bending and accretion disk were realistic. That movie taught millions of people what a black hole actually looks like. Pop culture has become a vehicle for spreading astronomical knowledge. Or consider the Starship Enterprise from Star Trek. In various episodes, the crew references real stars and constellations. They visit planets in the Rigel system. They navigate using stellar cartography. The show treats space as a real place with real geography, not just a fantasy backdrop. And that's influenced how audiences think about space exploration. It's made the universe feel more accessible, more knowable. Star Wars, on the other hand, takes a different approach. It's fantasy. The stars are just scenery, and that's okay too. Both approaches have value. One inspires scientific curiosity. The other inspires mythological wonder. Both are rooted in our ancient relationship with the stars. Then there's the commercialization of the stars. Have you ever seen ads that say, "Name a star after someone you love"? Buy a star naming package and you'll receive a certificate saying that a star has been officially named in honor of your partner, your parent, your child. It's marketed as a romantic gift, an eternal memorial. But here's the hard truth. Those star naming companies are scams. Not in the sense that they won't send you a certificate. They will. But that certificate is meaningless. The International Astronomical Union is the only organization with the authority to officially name celestial objects, and they don't sell star names. They assign names and designations based on scientific criteria, and those names are used in professional astronomy. The names you buy from commercial companies aren't recognized by any scientific body. They're not in any official catalog. They're not used by astronomers. You're essentially buying a piece of paper that says, "We put this name in our private database." You could do the same thing yourself for free. Write your own certificate. It would be just as official. The stars don't care what we call them. But the commercialization of astronomy, the idea that you can buy a piece of the cosmos, reflects our enduring desire to connect with the universe, to claim some small part of it as our own. Even if that claim is purely symbolic, there's something bittersweet about that. On one hand, it shows how much we value the stars. We want to honor people by associating them with something eternal. On the other hand, it shows how disconnected we've become from the actual sky. Most people buying those star naming packages will never look up and find the star they supposedly named. They don't know how. They don't have access to a dark enough sky. The certificate becomes more real to them than the star itself. And that's a kind of loss, a loss of direct experience. The ancient peoples who first named the stars knew them intimately. They watched them every night. They memorized their positions. They understood their movements. Naming a star meant something because you had a relationship with it. Today we're naming stars we'll never see for people who will never look for them. The meaning has shifted from practical to purely sentimental. And maybe that's inevitable in a world where most of us live under light-polluted skies. But it's worth recognizing what's been lost. Let's end this section with something more hopeful. The way constellations have evolved in literature and art. Poets have written about the stars for millennia. Shakespeare referenced constellations throughout his plays. "Doubt thou the stars are fire," Hamlet says. "Doubt that the sun doth move. Doubt truth to be a liar, but never doubt I love." Stars as symbols of constancy, of truth, of eternal beauty. That theme runs through countless works. John Keats in Bright Star wrote, "Bright star, would I were steadfast as thou art." The stars represent what we wish we could be, unchanging, eternal, reliable. Even though, as we now know, the stars are anything but eternal. They're born, they live, they die, they move and change and eventually burn out. But the illusion persists. The feeling that when we look up at the stars, we're connecting with something permanent, something that was there before us and will be there after us. And maybe that's what we need them to be. Not scientifically accurate, but emotionally true. A reminder that we're part of something larger, something that transcends our brief lives. Constellations have adapted and survived because they're flexible. They mean different things to different people. To a Babylonian farmer, they were a calendar. To a Greek poet, they were mythology. To a Polynesian navigator, they were a map. To a modern astronomer, they're coordinate labels. To a child learning the sky, they're a treasure hunt. To someone who's lost a loved one, they're a memorial. All of these meanings coexist. All of them are valid. And that's the resilience of constellations. They're empty vessels. We pour into them whatever we need. Hope, meaning, connection, memory. And they hold it all without judgment, without change, shining down on us exactly as they've always done. Which brings us to the final question. After thousands of years of telling stories about the stars, after mapping them and naming them and finding meaning in them, what's left to say? What do the stars mean to us now, in an age of space, telescopes and interstellar probes, in an age when we've walked on the moon and sent our machines to the edges of the solar system? Are constellations still relevant? Or are they relics of a prescientific past? That's what we'll explore in our final moments together. Let's return to that image from the very beginning. A campfire, 40,000 years ago. A group of people sitting in the darkness, looking up at a sky so full of stars, it's almost overwhelming. And someone points, "There, do you see it?" And in that moment, a story begins. A pattern is recognized. A connection is made between earth and sky. between human imagination and cosmic reality. That moment has never ended. We're still having that conversation, still pointing, still finding patterns, still telling stories. The technology has changed beyond anything those ancient stargazers could have imagined. We've built telescopes that can see the birth of galaxies billions of light years away. We've sent spacecraft beyond the edge of our solar system. We've walked on the moon and driven rovers across Mars. But when we look up at the night sky, we're still those same people, still trying to understand, still seeking connection, still finding meaning in points of light scattered across the darkness. Here's what's remarkable. In an age when we know more about the universe than ever before, when we understand that stars are fusion reactors powered by quantum mechanics, when we've mapped the cosmic microwave background and detected gravitational waves from colliding black holes, we haven't stopped seeing constellations. We haven't abandoned the stories. If anything, we've added to them. We've created new myths for a new era, and that tells us something profound about human nature. Knowledge doesn't replace wonder. Understanding doesn't eliminate meaning. We can know that Orion's belt is an optical illusion and still feel awe when we see it. We can understand stellar evolution and still call the Pleiades the Seven Sisters. Science and story aren't enemies, they're partners. Both are ways of making sense of the cosmos. Both have value. If this journey through the history and meaning of constellations has touched you, I'd be so grateful for a like. And if you've stayed with me through this entire exploration, thank you. Truly. If you'd like to join us for more gentle expeditions through science and history, please subscribe. There are infinite stories waiting among the stars. Let's talk about the new constellations we're creating. Not official ones, not patterns of stars, but symbols of our current age projected onto the sky. The International Space Station orbits Earth every 90 minutes. On a clear night, if you know when and where to look, you can see it. A bright point of light moving steadily across the sky, brighter than most stars, crossing from horizon to horizon in just a few minutes. It's not a star, it's a laboratory. A home for astronauts from multiple nations working together 250 miles above Earth. But when you see it, it feels magical. It feels like a new kind of constellation, a human-made star, a symbol of what we can achieve when we work together. Children who see the ISS pass overhead are seeing something their grandparents couldn't have imagined, a permanent human presence in space. That's a new mythology being written in real time. Or consider the satellites. There are thousands of them now. Communication satellites, weather satellites, GPS satellites, scientific instruments. And increasingly you can see them, especially the Starlink satellites, which have caused controversy among astronomers because they're so bright they interfere with observations. But to the average person looking up, they're a new phenomenon. A train of lights moving in formation across the sky. Unnatural, technological, but also beautiful in their own way. We're filling the sky with our creations. We're making our mark on the cosmos. And future generations will have to navigate a sky that's both natural and artificial, the stars and the satellites, ancient light and modern technology, coexisting. Here's a thought experiment. Imagine an exoplanet orbiting a star in the constellation Andromeda. Imagine there's an intelligent civilization there looking back at our sun. What would they see? Our sun would be just another faint star in their sky, not part of any constellation they'd recognize. But if they had powerful enough telescopes, if they could somehow observe Earth, what patterns would they draw? Would they see anything in the arrangement of our solar system that would inspire stories? Would they tell myths about the third planet from the sun? The one with the single large moon? Would they notice that we're here, sending out radio signals, launching spacecraft, changing the chemistry of our atmosphere? And if they did notice, would they create a constellation to mark our location? A pattern that says, there, that's where the others are. It's a beautiful reversal. For all of human history, we've been looking up and creating patterns. But somewhere out there, maybe someone is looking toward us and doing the same thing. creating meaning from our existence, writing stories about Earth. We haven't found them yet. We don't know if they exist. But the search itself is a kind of constellation making. SETI, the search for extraterrestrial intelligence, listens to the stars, hoping to find patterns in the radio noise, signals that couldn't be natural, messages from other civilizations. And when we send our own messages into space, like the Voyager Golden Record or the Arecibo message, we're doing the same thing ancient peoples did when they named the stars. We're asserting that we're here, that we matter, that we want to be remembered. We're writing our story in the cosmos, hoping someone somewhere, sometime will read it. Let's bring this back to Earth, to the personal, to you. When was the last time you really looked at the stars? Not a glance as you walk to your car, not through a city haze where you can barely see a dozen points of light, but really looked, sat outside. Let your eyes adjust to the darkness. Let the sky reveal itself. Most of us haven't done that in years, maybe decades. We've lost access to the night sky, not because the stars have gone anywhere, but because we've buried them under light pollution. The Milky Way, that river of stars that inspired countless myths, is invisible to about 80% of people in North America and Europe. Most children growing up in cities have never seen it. They don't know what they're missing. And that's a tragedy. Not just an aesthetic one, but a psychological one. Because looking at the stars does something to us. It puts things in perspective. It makes our problems feel smaller, our lives shorter, but also more precious. It connects us to something larger than ourselves, larger than our countries, our species, our planet. It reminds us that we're part of a universe that's been unfolding for 13.8 billion years, and that we have the incredible fortune to be alive during the brief moment when that universe can look back at itself and understand what it's seeing. You don't need a telescope to experience this. You don't need to know all the constellation names or the scientific details. You just need darkness and patience and a willingness to look. If you can get to a dark sky location, do it, even once. Find a state park or a rural area away from cities. Go on a night with no moon. Give your eyes 20 minutes to adjust, and then look up. You'll see what your ancestors saw. The Milky Way arcing overhead. Thousands of stars. The depth and dimensionality of space. And you'll understand viscerally why every culture that's ever existed has told stories about the sky. Because it demands stories. It demands explanation. It demands wonder. Here's something you can do tonight. Even in a city. Even with light pollution. Find the North Star. Use the Big Dipper as your guide. The pointer stars at the end of the bowl point right to it. Polaris. It's not the brightest star in the sky, but it's the most important one for navigation. It marks the North Celestial Pole. And here's what's beautiful. When you look at Polaris, you're looking at a star that's about 433 light years away. The light that's hitting your eyes tonight left that star in the year 1592, when Shakespeare was writing, when the first European colonists were arriving in the Americas. That photon has been traveling through space for over 4 centuries just to reach you. And it will continue past you, past Earth, out into the vast darkness beyond, carrying with it the information that once briefly it reflected off your retina. You touched a piece of the universe, and the universe touched you back. That's not metaphor, that's physics, and it's profound. Every culture has made this connection in their own way. The Babylonians through their star catalogs, the Greeks through their myths, the Chinese through their celestial bureaucracy, indigenous peoples through their seasonal calendars and navigation systems, and now us through our science and our technology. But underneath all the different approaches, there's one constant: the need to look up, the need to understand, the need to feel connected. Constellations are how we've satisfied that need for thousands of years, and they still work, they still matter, because they're not about the stars. They never were. They're about us. So, what do the stars mean in the 21st century? They mean the same thing they've always meant. They're a mirror, a canvas, a reminder. They're where we project our hopes and fears and dreams. They're where we write our stories. And as long as humans exist, as long as we're capable of looking up and asking, what does it mean? We'll keep writing those stories. The constellations will keep evolving. New patterns will emerge. Old ones will fade, but the impulse will remain. Because we're storytelling creatures. And the universe is the greatest story ever told. Thank you for taking this journey with me, for traveling from ancient Mesopotamia to modern astronomy, from campfires to space stations, from the first stargazers to the last. We've covered a lot of ground, or rather a lot of sky. But there's always more to explore, more to discover, more to wonder about. The stars are patient. They'll be there when you're ready to look up again. And I hope you will. Not because you have to. Not because there's a test or a requirement, but because it's worth it. Because in a world that often feels small and complicated and overwhelming, the stars offer something rare: perspective, beauty, connection, and the reminder that we're part of something much, much larger than ourselves. If you enjoyed this exploration, if it made you think or feel or see the sky a little differently, I'd love to hear your thoughts in the comments. And please share this with someone who needs to remember that the stars are still there, still shining, still waiting. We have more cosmic stories coming soon. More journeys through space and time. More moments of wonder told softly. Until then, on the next clear night, step outside. Look up and remember. You're looking at the same sky your ancestors saw. The same stars that guided sailors and inspired poets and marked the seasons for farmers. You're part of that long, unbroken chain of stargazers. And maybe you'll see what they saw. Not just stars, but stories. Not just light, but meaning. Not just the universe, but home. Sleep well, friends, and keep looking up.